So explain 3 is having us apply what we learned about base E functions to actual problems from the real world. So the first problem we see is the Dow Jones Index is a stock market index used on the New York Stock Exchange. So if you ever watch the news, you probably see that thing going up and down all the time. And the Dow Jones Index from 1980 to 2000 can be modeled using this function, where T represents time after 1980. And what they want to know is how many years after 1980 would the index potentially reach about 3,000. So the first thing we're going to do is we're going to use our graphing calculator to graph this function. We first have to write it, right? So the first thing we're going to do is kind of figure out what our function would look like, which, I mean, they wrote it for us anyways. So we could just graph this using Desmos.com to figure out at what point this would be $3,000, but they also want us to not just solve using a graphing calculator, but also to determine the growth rate. So before we go and jump into Desmos.com, we're actually going to figure out the growth rate of this. So just so you know, in order to find this, we would find that our growth rate is actually equal to e to whatever power that is written. So I'm going to write this out as 1 plus r equals e to the c value. So that'd be 1 plus r, and in this case that'd be e to the 0.121 or 0.121. And I'm going to go ahead and solve this out for r. So what's being added to r? A 1, right? What's the opposite of adding? Subtracting. So that means r is equal to e 0.121 minus 1. We can actually simplify this out in our calculator, so let's go ahead and figure out what e to that power would be. And that would be about 1.12. Take away 1, which is about 0.2. So there's our growth rate. So our growth rate is about 0.12 as a decimal, and about, so we can figure this out as a percentage, that'd be about, go ahead and work that out, 12%. So we found our growth rate. Now we can actually use Desmos to graph this function and figure out at what point there will be $3,000 for the Dow Jones Index. Alright, so we're going to again use Desmos.com. So I open this up. This is actually from a previous section, so I'll go ahead and erase this. I'm going to, instead of writing, in this case, the Dow Jones as a function of time, I'm going to write y equals, and I'm going to write 878 to the e power. Now you can see here, you're like, where is e? So I can use my keyboard to write that in, or I can use one of the many functions here to write that in. It's up to you, but I'm going to write e to the exponent. So I'm going to use my exponent key here to the 0.121, and instead of writing t, I'll write x, and you see, oh, there's my graph. Okay. I'm also going to write in my second function of y equals, they want to know at what point the Dow Jones reached $3,000. Just had to look back at the problem. So I see that they do cross. Now if your graph does not look like mine, we can always zoom in. Again, mine has a touch screen, so I can kind of stretch my y or my x-axis if I need to. But in this case, it looks like they both cross. And they cross at $3,000 after about 10 years. Okay, so let's go ahead and write that in. So using the point that they gave us, that was after about 10 years, it hit about $3,000. So after about 10 years, the Dow Jones could be predicted to hit about $3,000. All right, so let's go ahead and go on to part B. So it says the Decay 225 index is a stock market index for the Tokyo stock exchange. And they can actually, from 1990 to 2010, they can model the growth using this function here, where t is the number of years after 1990. And they want to determine how many years after 1990 that the index would be worth about $15,000. So before we do that, we're going to again find out what the decay factor is. So because you'll notice for this one that this is a negative number, that it's actually decaying, it's going down. Not a positive thing to think about, but it's going down. And what we're going to do is we're going to equate 1 take away r, since it is decaying, to our value here. So we're going to take some time before we actually graph this out to figure out what this would be. So this would be 1 take away r equals e to the negative 0.0381 power. Okay. The next thing we're going to do is we're going to solve for r. Okay, so what is the opposite of a positive 1? A negative 1, right? So I'm left with negative r, e negative 0.0381, take away 1. And then we're not done with solving for r yet. We're actually going to, well, how many negatives are right here? 1, right? And what's the opposite of multiplying? Dividing. So we're going to take some time to actually simplify this out to an actual number value. So take some time either using a graphing calculator or for a calculator that you're using online to figure out what e to the negative 0.0381 take away 1 divided by 1 is. So for this one, that would be about 0.03738. And if you are wondering, you're like, I can't figure this out, I don't have a graphing calculator, I'm going to just take a time to kind of show you on Desmos how we would use that. So I pulled up Desmos.com. And instead of writing the graphing key, I'm actually going to use the scientific calculator. And it's going to load. And I'm left with this. This is kind of cool. Alright, so let's go ahead and work this out. E. Oh, that's nice. But I don't want just e, I want e to the negative 0.0381. And I want to take away 1. And you know what else I want to do? I want to divide by negative 1. So I'm going to put a parentheses around this. And I'm going to divide. Ooh, that's cool. Kind of gave me a fraction. That's nice. Negative 1. And that would be, yes, Mrs. A is right. I just wanted to check. But this is awesome. An awesome function that you can use, and notice it has a fraction, it has exponents, it's got that nth degree. There's so many things, and I'll go ahead and include more tutorials on this, but this is a great tool you can use for not just this section, but for the next upcoming sections in this credit. Alright, let's go back to our problem though. So our rate of decay is about that as a decimal. Now to change it to a percent, we are going to multiply by 100. So take some time on your calculator and figure out what that would be. And you should get something like 3.738%. Alright, so we kind of figured out its decay rate. Now we want to figure out, okay, at what point would it be $15,000. So let's go back to our Desmos calculator. So I pulled up the graphing one again, and I'm going to, instead of writing y equals my old function, I'm going to write in 23,500 to the e, or times e to the negative 0.0381. And instead of writing t, I'm going to write x, and they want to know at what point that would be $15,000. So let me go ahead and maximize this screen and see what that would be. Oh, it does cross. So after about 11.7, so 11.7 years, it'll be worth about $15,000. So let's go ahead and write that in here. So after about 11.7, so about 11 years after 1990, it should be worth about $15,000, and I can work that out. So 1990 plus about 11 years, that would be about 1, 0, 1. So about 2001. Check me on that. But yeah, about 2001 or about 11.7 years, or, you know, since it's 0.7, maybe 2002. Okay? Alright. It looks like we did part A and part B, so go ahead and pause here and do the Explain 3 in your packet. I really hope that the tool I showed you, not only for graphing using Desmos, but also for using Desmos as a calculator, especially for this section, helps out a lot. Alright,